Hello, my name is Jim Gerber, and I'm the Advanced Placement Calculus teacher at the American School Foundation of Monterrey in Monterrey, Mexico. This is going to be the first in a series of 6 or 7 videos, I suppose, on the topic of polar coordinates and polar curves. In this video, I'm going to just discuss the basics of what polar coordinates are and how to plot points in the coordinate plane. So in order to talk about what are polar coordinates, the first thing we have to understand is that in your lives, pretty much everything you've ever dealt with in terms of plotting points has been on a Cartesian coordinate system. In other words, in a normal XY plane. And the way that you've plotted points all your lives is the point XY, you start at the origin, you move X units to the right or left, and then when you get there, you move Y units up or down, and you plot the point. And you've done that for a long time, and I'm sure you're all very good at that. But that's not the only way to locate a point in 2 dimensions. That's certainly one way, but it's not the only way. So to take a look at this, let's take a look at the old Cartesian system. So here we are at the origin, and if I want the point xy, I move x units along the x-axis, and then I move up y units, and I find the point x comma y. No problem. But I could do this same point a different way. I can imagine starting here, but instead of going x units over, I can imagine going along some length r, and then putting a point on the end of that and creating a line segment. And then if I took this line segment of length r and rotated through an angle of theta degrees, or theta radians, I would end up at this same point. But now, instead of thinking about going over x and up y, I'm thinking about rotating from the positive x-axis through some angle theta, and then going r units away from what we used to call the origin. In polar coordinates, this is not called the origin. In polar coordinates, this is called the pole. And so, again, I rotate through an angle of theta degrees, or theta radians, and then I move a distance r away from the pole. And I get this same point. You'll notice that this point in the first coordinate is the same on both diagrams, but the way that we get there and the way that we label it is completely different. In a Cartesian system, we label it xy, meaning go to the right x and go up y. In a polar system, we label it r theta, meaning rotate through an angle of theta and then move r units away from the pole. So that's the beginning of polar coordinates. Okay? xy we call a Cartesian coordinate, r theta we call a polar coordinate. Now, one thing that you need to understand about polar coordinates, which is probably not immediately obvious, is that this distance r doesn't have to be positive. So what would it look like if r was negative? Well, it's pretty much exactly the same thing. The only difference is if I had the point r theta and r was, say, -6, then what I would do is I would rotate through an angle of theta degrees, whatever that is. I'd rotate through that angle of theta, and then instead of going out here 6, I'd want to go -6, which means I would go in the opposite direction. So I would be back here, and this would be the point 6 comma theta. Sorry, this would be the point -6 comma theta if this is the point 6 comma theta. Okay, let me show you what I mean with a more specific example. Consider the point 2 comma pi over 6 and -2 comma pi over 6 in polar coordinates. To get to 2 pi over 6, I imagine rotating through an angle of pi over 6 radians, or 30 degrees, and then moving 2 units away from the pole. In other words, I rotate through an angle of pi over 6 radians from the positive x-axis, and then I go a distance of 2 units from the pole, and this blue point is the point 2 comma pi over 6. The point -2 pi over 6, I would start the same way. I would rotate through an angle of pi over 6 radians, but now, instead of going 2 units from the pole, I imagine going -2 units, which puts me in the opposite direction. I rotate 180 degrees, and this would be the point -2 comma pi over 6. I rotate pi over 6 radians, and I go -2 along that line. Now, one important difference between polar coordinates and Cartesian coordinates is that in Cartesian coordinates, any given point is unique. In other words, if this is the point, let's imagine that this is the point 4 comma 3. In other words, I've started here, I've gone 4 units to the right, I've gone up 3 units, this is the point 4 comma 3. That is the only way to label that point. Okay, if this is 4 comma 3, that's the only way of labeling it. If I change that, if I change it to say 5 comma 3, that puts me over here someplace. If I change it to 4 comma 4, that puts me up here someplace. The only way to get to this point is with 4 comma 3. And so each point is uniquely labeled in the Cartesian coordinate system. But in the polar coordinate system, that's not true. In fact, there are an infinite number of ways to label any given point. Why is that true? Well, let's think of a specific example. Let's imagine the point 5 comma pi over 3. If I wanted to graph the point 5 comma pi over 3, I would say, well, let's start on the positive x-axis. Let's imagine rotating through an angle of pi over 3 radians, in other words, 60 degrees. So I'm up here someplace. And then I move along a distance 5, and I say, okay, that would be the point 5 comma pi over 3. But there's a lot of different ways of getting that same point. So 5 comma pi over 3 might look like this. I can imagine going pi over 3 radians and a distance of 5, like I just said. But what if I said, imagine the point 5 comma negative 5 pi over 3? Well, pi over 3 is 60 degrees, so negative 5 pi over 3 is negative 300 degrees. And if I wanted that point, I would start here. I would imagine rotating around through negative 300 degrees, or through negative 5 pi over 3, and then going a distance of 5, and I would see that I would be on the same point again. So this point could be 5 comma pi over 3, or it could be 5 comma negative 5 pi over 3. It's the same point. There's other ways as well. For example, I could start here, and instead of going pi over 3, I could imagine going 4 pi over 3, which puts me on this red dotted line. And then if I went a distance 5, it would put me down here. But remember, if I go a distance negative 5, I go in the opposite direction. So negative 5 comma 4 pi over 3 would fold me back up to here. So this point could also be negative 5, negative 5, 4 pi over 3. And likewise, I could also get to this red dotted line. Instead of going 4 pi over 3 this way, I could go 2 pi over 3 this direction. In other words, negative 2 pi over 3 radians. That gets me on the red dotted line, and then negative 5 is going to fold me up to here. And so I've also got the point negative 5, negative 2 pi over 3. So we see that that's 4 different ways of labeling this same blue point. But of course, if there's 4 ways, there's an infinite number of ways, because there's an infinite number of ways of labeling every one of these angles. In other words, I can say that this is an angle of 60 degrees, or I could go all the way around again and call it an angle of 420 degrees. So in other words, this could be 5 comma pi over 3, but it could also be 5 comma 7 pi over 3, 5 comma 13 pi over 3, 5 comma 19 pi over 3, and so on and so on. I could get an infinite number of ways, and likewise with all of the other angles. If I add or subtract 2 pi radians to any of those angles, I land on the same spot. And so we see that there are, in fact, an infinite number of ways of labeling any point in a polar coordinate system, unlike in a Cartesian coordinate system where there's always only one. The last thing I want to talk about is just a little bit of nomenclature. In Cartesian coordinates, the intersection of the x and the y axes is called the origin. Okay, that's what you've always called it. But in a polar coordinate system, the intersection of those two axes is not called the origin, it's called the pole. Okay? In Cartesian coordinates, the origin has the coordinate 0, 0. But in polar coordinates, it could be 0, 0, but it could really, if you think of it, it could be 0, anything, right? Because if I imagine, what would the point 0, 90 degrees look like? 0, pi over 2. Well, I would rotate pi over 2, so I'd be on the y-axis, and then I'd go a distance 0, so that's going to put me at the pole. So 0 pi over 2 is at the pole, 0 pi is at the pole, 0 pi over 7 is at the pole. Anything with the first coordinate is 0 is going to be at the pole. And so the pole has coordinate 0, theta, where theta can be any angle that I want it to be. So I think that's as far as I'm going to go with this first lecture. I don't want these to get quite so long. So I'm going to stop this one here, and then I'm going to create the second part of this lecture, which is going to deal with converting between polar coordinate systems and Cartesian coordinate systems.